and I had also explained you what is buffer. It is a buffer which is used to provide extra current drive at the output. We also discussed about the inverter. Inverter means which inverts the data. So inverter. So and OR gate also we had discussed about the truth table of and OR gate, and we had also discussed about the OR gate. OR gate, how the OR gate works. So today, hope so the symbol is also clear to you people. So and or, when you write it properly. Sometimes you will do the mistake while writing and or gate. So don't do it. Okay, write it properly. So coming into the next topic. So NAND and NOR gate. So the name itself says NAND. So N has been appended to a AND gate. It works opposite to the AND gate. Okay. So just you can see the diagram here. For the same diagram, NOT symbol is being connected. For the same diagram here, the NOT symbol is connected. It means NOT of AND. I repeat it. It means NOT of NAND. So here the gates will only produce the logic 0 output when all inputs are simultaneously 1. It is a vice versa table of the AND gate. So here you can see the truth table 001, 011, 101, 110. So gate will only produce logic 0 output when all inputs are simultaneously 1, and other input combination will produce a logic 1 output. NAND gate is an AND gate with its output inverted. You can see here the circle shown at the output denotes this inversion. So this is all about your NAND gate. Understand the concept? NAND gate, it is a opposite. It works opposite of the AND gate. It is a NOT of AND. Truth table, whatever you are writing for the AND gate, you need to write the opposite values of it. Okay. Output, what you get will be the inverted values. So coming into a NOR gate. NOR gate means not of OR. Not of OR means it is opposite of the OR gate. Whatever the truth table you get, you can see the diagram also. For the output, there is a NOT which is being connected. That NOT which is being connected, hence it works as a NOT of OR gate. Here the gate will only produce a logic 1 when output when all inputs are simultaneously at logic 0. Other input combination will produce a logic 0 output, and a NOR gate is an OR gate with its output inverted. A circle is used to indicate the inversion symbol here. So hope so NAND and NOR is clear to you people. So coming into a exclusive OR gate. So here what do you mean by exclusive OR gate? So for the same you can see it gives the output. The output will be 1 only when any one of the input is high. Okay. Exclusive OR gate will produce a logic 1 output whenever either one of the input is at logic 1 or other is at logic 0. So exclusive OR gate is used to produce a logic 0 output whenever both the inputs have same logic state and Boolean expression for output Y of an exclusive OR gate is given with the input of A and B. You can see the symbol here, how it has been written here in this way. Okay, this is how it is being written. Okay, coming into the next topic. So what are the gates did we discuss? Combinational logic. I'll tell you what are the topics we discussed. We discussed about the logic gate. In the logic gate, buffer, inverter, NAND, AND, OR, NAND, NOR, as well as exclusive OR. So before we jump on to the combination, so now we will look into the combinational logic. So coming into a combinational logic, so what do you mean by combinational logic? Okay, so combinational logic means, we'll look into it. So a logic circuit is to be constructed that will produce a logic 1 output whenever 2 or more of its 3 inputs are at logic 1. So here, so it means you can see you need to construct a circuit by using and OR gate. So what they are saying here, they are saying it is a 3 input. So this is an example, as I had said you. So they have in the question, they have already given you that if it has 2 or more inputs are you need to realize it. So what you do is, you are taking a truth table, you are taking an input as A, B, C and output as Y. So you have written a binary input value, it will be same. It is nothing but 1, 2, 3, 4, 5, 6 and 7. These are the input which is being written in the binary value. So output, we need to look into the output. So what we are doing here is, so what they are saying here, so it should produce the output as 1. The logic circuit is constructed such that it produces logic 1 output. Output should be logic 1. So what we do, we will realize it. So 0, this will be 0, 0, output 1. So we can write this as BC. So here we can write it, we don't have an output, so hence we are not considering. Wherever the output is 1, we are considering a expression with respect to that. Okay, so here when it is 1, with respect to that B and C, so with respect to this 1, A and C, so with respect to 1, A and B, so with respect to 1, A, B, C. So what we do, we will write this. So that is nothing but B into C plus A into C plus A into B plus A into B into C. Okay, then we will write down the logic symbol for this. So we know if it is into, we can write it as AND gate. If it is plus, we are supposed to write it to a OR gate. So here we have used a AND gate and OR gate to realize the, so you can see here, so here AND and OR, the output is given to a OR gate. So here if you realize this expression, the output will be the logic 1. Okay, so next we are taking one more example, and the one more example you can see here. So it shows how an arrangement of basic logic gates AND, OR and NOT can be used to the exclusive OR function. So they have given an expression as y is equal to a into b bar plus b into a bar. So by this we will realize it by using and, or, and not. In the exam they will specifically ask you. So here you can see how it has been written. They have used the and, nor, and, or, and not gate. Okay, so you can just write it as whatever we want. What do we want? We want a into b bar. B bar means we get it from a not gate. So b into a bar. A bar we will get it from a not gate. So how do we realize it now? So a and b, we will take a and b, a input line. So next we will take a NOT gate from it. Okay, I repeat it. We are taking a NOT gate. We can connect it a NOT gate directly here. So I will connect here. Okay, 1 second. So here I can write it in this way also. In this way also, this is also correct. It is here for your understanding. So here I can take a input. So if I take a input here, it will be A, it will be B. Here it will be A bar, here it will be B bar. Okay, the same way they have done here. So here what it happens is we want, I'm just giving you an example here. I'll write down the expression and I'll realize it. Y is equal to A into B bar plus B into A bar. So here this operation says it is and this operation says it is or. So it is very clear for you people. So I'll write down the AND gate. For AND gate, one input is A. I'll directly connect it. So one more input is B bar. So again I'll write on the AND gate. B is a straight input. So B bar is one more input. So I'll write a NOT gate here and I'll give it as a input to one AND gate. So again here B is the input which is given and A bar is a output which is one more input which is given. So I'll write it in this way. Anything is fine. So here A bar B, A into B bar. So output what do I get? A into B bar, B into A bar. So both we have got. We want a plus symbol. So what do? We'll connect it to a OR gate. So hence we get this. So look into it, understand it and write it. Okay. You might get the same kind of example in the exam also. Understand the concept, don't mug it up. So it is very clear. So we will look into the next topic. So next topic, it deals with the bistable elements. Okay, here bistable elements, the output of the bistable has two stable state, that is logic 0 and logic 1. Once set in one or other of these states, the device will remain at a particular logic level for an indefinite period until the reset button is pressed. So a bistable thus constitute a simple form of memory cell because it will remain in its latch state until a signal is applied to it in order to change its state. So what did you understand here? Bistable, it is nothing but it has a two stable state. Okay, so the output of the stable state has two stable state as I had you. So again you have an RS bistable. The simplest form of bistable is R and S bistable. The device has two inputs, set and reset, and a complementary output, that is Q and Q bar. So the logic 1 is applied to set the input while we will cause a Q output to become a logic 1, while a logic 1 applied to the reset input will cause the Q output to become a logic 0. The bistable will remain in its set or reset state until an input is applied in such a sense as to change the state. The two simple form of RS bistable, based on cross-coupled logic gate using an and nor are shown here. So you can see the two diagram here, set and reset, how it has been given. So that is Q and Q bar is an output. It is with respect to a NAND gate. You have come across what do you mean by NAND gate. So this is a NAND gate and this is a NOR gate. So with respect to NAND and NOR, bistable, RS bistable element has been connected here. Okay. By this we will end this class. We'll look into the other topics in the next class. Thank you.